Now lecture 1, vector analysis. First of all, we have to know about the what is electromagnetics. So first of all, electromagnetics. So what is electromagnetics? It is nothing a branch of physics or electrical engineering in which electric and magnetic phenomena are studied. So we can define it. EM is a branch of physics or electrical engineering in which electric and magnetic phenomena are studied. Electric and magnetic phenomenon are studied. The branch of physics or electrical engineering in which electrical and magnetic phenomena are studied is called electromagnetics. Okay, now we have to know about Maxwell equation. Maxwell's equations. Okay, so first Maxwell equation is this is the Dale operator, rho v, equation number 1. Second one is del dot b is equals to 0. And now third equation is curl of E is equals to minus del b by del t. This is nothing but the vector notation, equation number 3. And fourth equation is curl of H, that is magnetic field intensity, here J plus del d by del t. Okay, this is equation number 4. So these 4 equations are Maxwell equations. Okay, where we have to know about these all terms, means what is d, what is rho v, what is b, what is e, what is h, what is j. These all we have to know, and we have to know also about these equations, how can derive these equations and from where it will come. So all we have to know. So about this equation we have to know what is d, where what is d. First of all, what is del? What is del? So del is the vector differential operator. Now d, the electric flux density. Write down everything. What is b? The magnetic flux density. Magnetic flux density. What is E? The electric field intensity. These are intensity E and H. Okay. What is H? The magnetic field intensity. Okay. And what is rho V? Del dot V del dot D equals to rho V is written, no? So what is rho V? Rho V is volume charge density. The volume charge density. Okay. And what is J? J is the current density. Okay. Now we all know about these terms. If already know, then okay. If you don't know, then you have to write down these terms. Okay. Now we'll discuss in electromagnetics one by one about these equations and how we can derive it, and where I will use these equations, or what will be the applications of the Maxwell equation. All we have to know. Okay. Now next one we have to know about the scalars and vectors. So heading scalars and vectors. Okay, we have to know about this. So scalar quantity what is a scalar? So a scalar is a quantity that have only magnitude, means it has only magnitude. Okay, means that quantity, the quantity which have only magnitude is called a scalar. Okay, and the vectors it has both magnitude and direction. Means the quantity which have magnitude and direction both, then you can say this quantity is a vector quantity. Okay. Now what about field? Field. We have to know about the field. What is field? Okay. So field is a function that specifies a particular quantity everywhere in a region. Okay. So what is field? Field is a function that specify a particular quantity everywhere in region. Suppose this is a region here, so we can say that this is a field. Okay, how we can say this is a field? if charge q is here, so this is a function that specify, means it's a function of z. So it's a function of a specify the region, that one is field. Now next one is so if this function, if this field, if a scalar field is there or vector field, how can define the scalar field or vector field? So a scalar field, in a scalar field only magnitude and vector field both magnitude and direction, Okay, so if this field is a scalar field, then you can say this has only magnitude, no direction. But if this field is a vector field, then it has magnitude and direction both. Okay. Now, unit vector. What is unit vector? Unit vector. So a unit vector whose magnitude, this is a vector, so it has magnitude and direction both. So a vector whose magnitude is unity and its direction is along the vector, and its direction is along the vector. Okay, so how we can represent it? So the representation of this unit vector is nothing but it is denoted by cap. Okay, so it is denoted by cap. So let's take an example here. If suppose A is a vector here, A is a vector, so a vector, if A is a vector here, this is a vector A, so it has magnitude and direction. But now what will be the unit vector of this vector? So we have to write here the unit vector of A. We can represent the A cap, or we can write here the small a cap. So small a cap is nothing but the vector and divided by its magnitude here, so that the magnitude of this vector becomes 1. Why? Because in a unit vector the magnitude will be 1 and its direction along the vector only. So this is the representation of the vector here. This is the representation of any unit vector. Okay. Now example taken that this is a vector which has a x along x cap plus a y along y cap plus a z along z cap. Okay, then what will be the unit vector of this vector? So unit vector of this is nothing but the vector divided by its magnitude. Clear? So that ax x cap plus ay y cap plus az z cap divided by its magnitude. What will be the magnitude of this? So magnitude of this is nothing but square root of ax square plus ay square plus az square. Okay, so I have to write it here that ax square plus ay square plus az square. So this is the unit vector of this vector. Now any vector we can represent in its magnitude with its unit vector, multiply with its unit vector. Now we have to know about the addition, subtraction, multiplication. We have to know. We already know that in 12th section or 12th standard we have already know about the vector addition and subtraction. Okay, so a little bit we have to focus on it. So addition, vector addition. Okay, vector addition. Now if A is vector added with B vector, then that one is equals to the B vector added by A vector. Okay, so this is commutative property, commutative law. Okay, now another one is associative law, associative property. It has associative property. What it say? If three vectors are there, if B and C vectors are added already and its addition, its resultant sum will added with A vector, then that one is equals to the, if first I add A plus B and then third vector C is added, then this one is equal. So it says that associative. Okay, now third one is distributive property. What distributive property say? If A and B vectors is added and another one k constant is multiplied with this addition, then we can multiply individually before addition, or after multiplying individually we can add, we will get the same result. Okay, so this is the distributive law. Okay, so we have to know in vector addition this law. Now position vector. Before position vector, we have more focused on vector multiplication. So vector addition and subtraction we all know. What about subtraction? Subtraction is nothing but the, suppose A vector subtraction is there. So what subtraction say? Subtraction means A minus B. What it say? It's nothing but addition. A plus of minus B. Means if here in this one A vector is this and B vector is this, we have to add. Okay, now the resultant will goes to this form C vector. Okay, but here if A vector is this one and B vector is this, then what is minus B? Minus B is this one. Okay, and B resultant will get in this direction. Okay, so subtraction is nothing but the addition only the negative term will be with the vector and direction will be opposite. Okay, so this is the vector addition. Now multiplication, we have to know about the multiplication. So vector vector multiplication. Vector multiplication. So vector multiplication, 4 type multiplication we have to know. Okay, 4 type multiplication we have to know. First of all, first one is a scalar multiplication, scalar or dot multiplication. Sometimes we can say dot product multiplication. Just like A dot B, this is the scalar multiplication. Why we are saying that this one is a scalar multiplication, that one I will discuss later. And what happened with this result. Okay, now vector or cross multiplication. So how you can represent it? This one, if 2 vectors are here, then this. Now third one, in multiplication, we have to know about the scalar triple product. Or if 3 vectors are here, A, B and C, then this one says the scalar triple product. Or fourth one is vector triple product. Okay, vector triple product. So vector triple product is nothing but A, B and C are vectors and we have to cross between them. Okay, so one by one we have to know about these 4 products, these 4 multiplication. Step by step we have to know. Okay, now dot product. Dot product or a scalar product. Dot product So the dot product of two vectors A and B written as A dot B. We have already discussed that dot product or a scalar multiplication we can represent in we can represent as A dot B and is defined geometrically as the product of the magnitude of A and B and cosine of the angle. Means we can say here the A dot B, if A vector is there and dot with B vector, then what we can write? We can write here the magnitude of A into magnitude of B of cosine theta. Okay, so what will be the theta? So if two vectors are there, A vector is this and B vector is this. So this is A vector, this is B vector. So angle between them is theta. Okay, so we can write here the A cos theta means projection in the along P, or B cos theta projection along A. Okay, so here we have written magnitude of A, magnitude of B into cos theta, where theta is angle between them. Okay. Now let's take example here. Example. If A vector is x cap plus ay cap plus az cap, we can represent in unit vector terms, and another one vector B is bx x cap plus by y cap plus bz z cap. Okay, so we have to multiply with this. Now what will be the A magnitude here? A magnitude will be ax square plus ay square plus az square. Okay. Now what will be the B magnitude here? Bx square plus by square plus bz square. Okay. Now we don't know about the angle between them because ax, ay, az, bx, by, bz, we all are variables. So we don't know about the angle. Okay. But we can multiply it, no problem. We can multiply it. So A dot B is nothing but x cap plus ay cap plus az cap multiply by dot product bx cap plus by cap plus bz cap. Now first term, this ax multiplied by these all three, so we can get here ax bx, and this unit vector also we have to write, so x cap into x cap, clear, plus ax by x cap y cap plus ax bz x cap z cap. Okay, now another one ay written, ay bx y cap x cap plus ay by y cap into y cap plus ay bz y cap z cap plus az bx z cap x cap plus az by z cap y cap plus az bz z cap into z cap. Let's check. Okay, this is ax bx here, ax ay az, bx by bz. These all are a scalar quantity. It has no direction. But when I multiplied this with x cap, then it has direction. I have already told you that this is the vector. So if this is the vector, then it has magnitude and direction. But individually in x coordinate system, this is the x coordinate, y coordinate, and this is the z coordinate here. Okay, so z component is this. So if vector is this, then this is the a vector which has component ax, ay, az. So along x direction, along y direction, along z direction, it has component. So this is a vector. Okay. Now similarly b vector will be there. So bx, by, bz is the magnitude along x, y, and z. Okay. So this product ax and bx is the magnitude, but the main thing is this one, x cap into x cap. So x cap, why? Because this has one magnitude, but it has direction, and direction will decide the theta angle. Okay, so x cap into x cap. So we can represent this axis or this coordinate. If this is a unit vector, then this in this direction x cap, this direction y cap, and along this direction z cap. So these all four are perpendicular to each other. So x cap will be 1. Is it clear? Why? Because cos 0, theta will be 0 between x cap and x cap. So cos 0, 1. Suppose we have to know about what will happen with x cap into x cap if this is a vector, or this is a unit vector. Okay, but unit vector is also a vector, no? So what? X cap magnitude into x cap magnitude into cos theta. So theta will be 0 degree. So cos 0, 1, and the magnitude is 1. 1 into 1 into 1 will be 1. Why? Because x cap is a unit vector. So here we are talking about its magnitude. So magnitude will be 1 and its magnitude will be 1 and cos 0 degree will be 1. If x cap into y cap I want to discuss, then magnitude of x cap into magnitude of y cap into cos of 90 degree. Why? Because the angle between x and y will be 90. So 1 into 1 into 0 will be 0. Clear? So here the x cap into x cap is 1. Okay. And x cap into y cap, what? It's 0. This one will be 0. This one will be 0. Why? Because angle between these two unit vector will be 0. This one will be 1. This one will be 0. This one will be 0. This one will be 0. This one will be 1. So if this term is 0, then the whole term will be 0. This whole term will be 0. This whole term will be 0. This one will be 0. This one will be 0. And this one will be 0. So only 3 terms will remain. What? Just check. So is equals to a dot b is equals to ax bx plus AYBY plus AZBZ. Clear? So if we multiply these two vectors, these two vectors, and if angle not given, then we can multiply simply, and its unit vector will work. If unit vector is along the other one, then it will be 1. If perpendicular to other one, then it will be 0. And if angle between these two vectors given, then simply put cos theta. Okay, so this is the example. Now some law it will follow. Another one thing is orthogonal vector. Orthogonal vector. So if two vectors are orthogonal or perpendicular, if two vectors are perpendicular here, suppose one vectors are this and another one vector is this, means A vector and B vector is along this. So it's orthogonal. Orthogonal condition is simply theta will be 90 degree. Then when theta will be 90 degree, then its dot product will be what? 0. So this is the condition of orthogonal. If any two vectors say when we will say two vectors orthogonal, if its dot product will be 0. Okay, now some properties are there. Properties are there. So if A dot B is this, then this one is equals to B dot A. Okay, this is said to be commutative property. Commutative property or commutative law. Okay, now if we multiply it with anyone, then no problem, we can multiply with anyone. The same property to this, no problem, this is the advantage. Now second one is, if A dot A is there, then what will happen? Its magnitude is multiplied and direction will be cos 0, 1. So its magnitude square means A square. I have already seen, no? Okay, so these are about the dot product. Now we will go to the cross product. Okay, now cross product is there. We have to know about the cross product. Cross product. So we have already know about cross product, that cross product is nothing but the A cross B. If we multiply it by these two vectors, we have to know about the what will be the result of this. So cross product A cross B. So A cross B is nothing but the magnitude of A into magnitude of B and to sine theta and along normal. Means its result, the result of this vector result of this vector is a scalar. The result will be a scalar. So that dot product says that a scalar vector. But in vector product, its result is vector. Why? Because this quantity says the magnitude. Why? Because this one is magnitude, this one is magnitude, and this one also give magnitude. But this one is the direction. So the vector which have magnitude and direction, it's called vector. So result will be vector. So that cross product says the vector product. Okay. Now what is An? An is unit vector which is normal to plane containing A and B. Means like this. If A vector is here and B vector is here, and angle between them is theta, so A cross B, I will put here in this direction. We have to move. Why? Because A cross B, not B cross A. A cross B means we have to put palm here, we have to put palm here, and we have to cross along this direction. So our thumb will go inside. Okay, so this one normal outside, direction of the result will be outside or inside. So in this case it will be inside. Why? Because our thumb direction is inside. If A vector along this and B vector along this, then what about the direction? What will be the direction of result? Then we have to move A cross B, means A cross B. So we have to put our palm here, and we have just cross our finger, and the thumb direction will be outside. So thumb direction will outside to this plane, means upward. So result, the direction of result will be upward. Okay. Now one thing we have to know, that if A and B, example, similar examples we have taken, we are going to take here that Ax not A vector. A vector is x along ay, y along az, z along, and B vector bx, x along, by, y along, and bz, z along. Okay, so if I want to find out the A cross B, then we can use one determinant method. That one is x cap, y cap, and z cap. We have to write here ax, ay, az, bx, by, bz. Okay. Now what will be the result of this determinant? We can solve it. What? Ay bz minus by az x cap plus x bz plus az bx minus ax bz y cap plus ax by minus ay bx z cap. Okay, so using this we can find out if we don't know the angle between this. If we know angle between this, then we can simply put the value and we will get. Then what about the direction? From where I will get the direction in this situation? So direction will be the normal to this plane. This plane means A and B plane. Okay, so AN is the normal to this plane, but in which direction? We have to find out using thumb rule. Okay, now A cross B, if there, then B cross, we cannot write B cross A. Okay, this will not equal. This is the property. Property is 1. Second property is, or either we can write here A cross B is equals to minus of B cross A. This one is equal. Why? Because minus is there, it will change the direction. We cannot write here that A cross B cross C. If three vectors are there, we cannot say this one is equals to A cross B cross C, because multiplication is not thing here. Here direction included, means if B cross C has direction suppose outward, and outward direction has multiplied with another A vector, and this vector is placed in another plane, so maybe its direction is along B, or along that plane in which B is placed, along that plane in which C is placed, maybe. So we have to find out using right hand thumb rule. Okay, now another one property is, if A cross B plus C is there, B plus C is there, then we can simply write A cross B plus A cross C. This is distributive law. It will follow distributive law. Okay. Now if x dot x, in similar fashion, what happened with x dot x means, if x dot x or y dot y or z dot z is there, then it will give the result 1. If x dot y or other one multiplied with other unit vector, then the result will be 0. Then what happened in cross product? If x cross x, if x cross x is there, then what? Then theta will be 0. So theta will be 0 means 0. Okay, how? Just check it. Means the magnitude of x multiply with magnitude of x, sine of 0 degree, and angle normal. Means it gives magnitude, but 1 dot 1 dot 0 means it will be 0. Okay, but direction along the normal to this plane, it's okay. Similarly, y cross y will be 0 and z cross z will be 0. Okay, but what happened when x cross y is there? Then what? Let's check. This one is x cap. We are considering only unit vector, no problem. Okay, so if x cap is there, so x cross y means along this, not y cross x. x cross y. So our in xy plane we have to put our palm and we have to cross our finger along x to y and check the direction of thumb. The direction of thumb will be upward and upward is z direction. So it gives z cap. Okay, and y cross x, then if y cross x means in this direction. So y put our palm in xy plane and cross our finger from y to x. Our thumb direction will be inside the z plane or negative side of z plane. So it will be minus of z. So is that these both are equal? No. So we cannot say that a cross b or b cross a are equal. But we can say a cross b is equals to minus of b cross a. Okay. Similarly, y cross z is x cap and z cross x is y cap. Okay. So for this convenience, we can write here in triangle this one. Okay. So x cross y z cap positive one, y cross z x cap, z cross x y cap. If I multiply here the z cross y, then what? Z cross y, then it will be negative 1. So it gives minus x, and x cross z, it gives minus y. Okay, so this term we have to consider. Now next, is a scalar triple product. A scalar triple product. So scalar triple product, we have to know about the scalar triple product. After that, vector triple product we have to know. So if A cross B, what happen? It's not going to write here. Okay, a scalar triple product similar. We'll discuss later a scalar triple product and vector triple product. Okay. After that, Cartesian coordinate system. We will discuss Cartesian coordinate system in next lecture. Thank you.